We import TensorFlow as TF. Then we print out the TensorFlow version that we are using. We are using TensorFlow 1.0.1. In this video, we're going to check for element-wise equality between two TensorFlow tensors by using the TensorFlow equal operator. To demonstrate this, we're going to create two TensorFlow constant tensors and do a comparison between them. Alright, let's get started. First, let's create our first constant tensor using TensorFlow's constant operation. It's going to be a 2 by 3 by 4 tensor. The first matrix is full of 1s that are all integers. The second matrix is full of 2s that are all integers. We assign it to the Python variable tf underscore constant underscore x underscore 1. Let's print out the tf constant x1 Python variable to see what we have. We see that it is a TensorFlow tensor. We see that the shape is 2 by 3 by 4, and the data type has been inferred to be int32. TensorFlow gave it a name. Let's now create our second TensorFlow constant using the tf.constant operation. We see that it is a 2 by 3 by 4 tensor. This time the first matrix, rather than being all 1s, is 1s, then a column of 3s, then 1s, then a column of 3s. The second matrix is a column of 4s, then 2s, then 4s, then 2s. So scrolling up a little bit, we see that the second matrix of the first constant was all 2s. This one is a combination of columns of 4s and columns of 2s. So when we compare them, we should expect that 2 will not be equal to 4. This column of 2s will be equal to this column of 2s. This column of 2s will not be equal to this column of 4s. And this column of 2s will be equal to this column of 2s. And we assign this TensorFlow constant to the Python variable tf constant x2. Let's print out the tf constant x2 Python variable and see what we have. We see that it's a TensorFlow tensor. TensorFlow gave it a name. The shape is 2 by 3 by 4, and the data type is int32. And we don't see any values yet for either of these two constants because we haven't run them in a TensorFlow session. Just to see what happens, let's try the TensorFlow equal operation using our two constants, the tf constant x1 and tf constant x2. Because this isn't being run in a TensorFlow session, what it returns is a TensorFlow tensor with the name of equal. The shape is 2 by 3 by 4. Again, remember that TensorFlow equal operation does element-wise, so it's not going to change the shape of the two tensors that we are comparing. And the data type now is BOOL, or bool, which stands for Boolean, so it'll be either true or false. However, we don't see the actual Boolean values because we haven't run it in a TensorFlow session. So now that we've created the TensorFlow constants, it's time to run the computational graph. We launch the graph in a session, then we initialize all the global variables in the graph. Let's now print our TensorFlow constant x1 Python variable in a TensorFlow session to see what's inside. We see that it is indeed a 2 by 3 by 4 tensor. All the values are 1s. In the first matrix, all the values are 2 in the second matrix, and the data type looks to be integers because we don't see any decimal points. Next, let's print our TensorFlow constant x2 Python variable in a TensorFlow session to see what's inside. The first matrix is a column of 1s, then a column of 3s, then a column of 1s, and a column of 3s. Second matrix is a column of 4s, column of 2s, column of 4s, columns of 2s, which is exactly what we expect. Now let's do the element-wise comparison between the two TensorFlow tensors using the TensorFlow equal operation, this time within a TensorFlow session. When we do that, we see that we get back a tensor that is 2 by 3 by 4, which is what we would expect given we're comparing two tensors that have that shape, and the results are Booleans. All of them are either true or false, and we can actually double check. So checking the first matrix, row of 1s compared to a row of 1s, each element 1 is equal to 1, true, 1 is equal to 1, true, 1 is equal to 1, true. The second column, we're comparing a row of 1s versus a row of 3s, so we know that those are all false. The same for the third column of each one and the fourth column of the first matrix. Comparing the second matrix, we have 2 versus 4. Those are not equal. 2 compared to 2, those are all true. 2 compared to 4, those are false. And 2 compared to 2, those are all true. Perfect, we were able to test the element-wise equality of two TensorFlow tensors. And finally, We close the TensorFlow session to release the TensorFlow resources used within the session. And that is how you check for element-wise equality between two TensorFlow tensors by using the TensorFlow equal operator.